Vector, we'll call it vector V. It goes from A to B. It has an initial point, which we'll call point A, that's where it starts, and has a terminal point, point B, that's where it ends. The magnitude of a vector is its length. What other shape have you learned in mathematics that looks like a vector?
Triangle.
Okay, triangle if we were to go like this, right? What other shape though? Think geometry. Did you say a line?
Yeah.
So I'm thinking, see if this one hits anybody. I'm thinking a ray. We also ray. Yeah, but the difference is a ray goes on forever. A vector stops at a point. So vector ends, whereas a ray goes on forever. Okay. So we can add vectors. We're going to do that in a second. Right now, we'll just quickly sketch these vectors. This is vector V right here. And so if you're going to sketch negative V, it's the same vector. The negative just makes it go in the opposite direction. Maybe drew that a hair too long. Try again. There we go. 2V is going to be the exact same vector. It's just going to be twice the length. How about 1/2 V? Half the length. And what about negative 4V?
4 times the length in the opposite direction.
Yeah, 4 times the length in the opposite direction. You guys got the idea, okay? So we can draw vectors with different direction and length or magnitude. So given this is vector A and vector B, let's sketch an example of negative A. So negative A would look like this. Negative B looks like that. And now we're going to draw a geometric representation of what A plus B is. So we're going to take vector A, and onto the end of A, we're going to place vector B. So we have A, and then we have B. And the destination which we arrive at, that helps us then define what vector A plus B is. So that's the geometrical representation of A plus B. We see vector A, we see vector B. Together they make that one vector A plus B. How would I draw A minus B, do you think? Yeah, I take A and then I attach onto it a negative B. And you can see that what is produced there is vector A minus B. How about the last one, B minus A? You take B and attach what onto it?
A.
Negative A. So this becomes vector B minus A. Not too bad? Okay. Just kind of learning the basics of it. You'll see the application here in a little bit. They come up a lot in physics and other math courses in the future. So something you want to have a decent feel for. Suppose that you had a vector or an initial point of A was equal to, we'll say, I'm sorry, let's try that again. Let's say you have the coordinate of AB and another coordinate of CD. And you wanted to place the vector in what's called component form. So we'll say that this is the initial point and this is the terminal point. Then a vector can be placed in what we call component form. And component form has kind of these parentheses, but they're V shapes. Off to the side. And what we're going to do to come up with the horizontal component is we're going to see the distance it travels to get from A to C, which is just C minus A. And that will become the horizontal component of the vector. The vertical component of the vector is going to be D minus B. So we'll do a basic example right here. I'm just going to sketch 3, 4. So I'm going to go over 3 and up 4. That's my initial point. And my terminal point is over 7. So 4, 5, 6, 7. And up 5. So are we okay with that vector that we drew? So now I'm just going to place it into component form. And this is all it means. How far did I travel to the right to get from one point to the other? 4. How far did I travel up to get to the next point? 1. That's it. Okay, 7 minus 3, 5 minus 4. Now, consider that vector 4, 1. If I were to draw 4, 1, I'd be over 4 and I'd be up 1. If you notice, the blue vector is identical to the red vector. It is simply translated back to the origin. So anytime you take a vector and put it in component form, it just takes it, puts it back to the origin. You don't have to draw the picture, just see if you can quick come up with the vector in component form right here. Got 7, negative 3. Very good. Okay, flip it over. Want to get through this page and then just a couple problems on the next side. Magnitude of a vector and direction. So just as you saw our good friend Vector on Despicable Me, we're going to identify the same pieces. And if you are given a vector, AB, that means that in order to locate that vector, we move A units horizontally and we move B units vertically. The magnitude of a vector is the length of the vector. We say the absolute value of the vector. Anybody tell me how you can figure that out?
A squared plus B squared equals C squared.
Yes. R is the same thing as the modulus, or the magnitude of your complex number, which is the same thing as the magnitude of a vector, which is equal to the square root of A squared plus B squared. So, absolutely nothing different from what we did in chapter 7.6. The only difference is that when we sketch the angles will be in degrees as opposed to radians. So we have theta right there. Anybody think of a trig formula I would use to figure out theta? Hint, you've done it before. Tangent of theta is equal to B value divided by A value. Find the magnitude of each vector and the direction. So this is kind of example number 1 of what you're going to have to be able to do come time of the test. We have the vector 5, negative 2. The first thing I want to do is I just want to find the magnitude, which is equal to the square root of A squared plus B squared. And notice we get the root of 29. People make that mistake on the test, though. They squared negative 2 and they come up with a negative 4. You should never have any negatives underneath your square root sign. Second part, we find the tangent of theta is going to be equal to the B value, which is negative 2 divided by 5. This is a mistake people make as well on the test. They don't locate their quadrant correctly. Which quadrant are we in?
4.
Yeah, the 4th quadrant. So your answer must be between 270 and 360 degrees. You know that because if you were to plot that vector, you'd be in the 4th quadrant. So I'm considering the fourth quadrant. Can somebody take their calculator and inverse for me, please, the tangent of 2/5? Make sure you're working in degrees and not radians. Degrees and not radians.
So we worked in radians for that last lesson.
Yes.
But
That's
then
something.
everything else in degrees.
Yes, exactly. And that's something we'll try to clarify before the test. That's something people generally have questions on.
Yeah.
Gunnar, did you get 28.1? 21.8? Trying to remember from the other classes. I obviously did not. We got 21.8 degrees. Some people will leave 21.8 as the result. That's wrong. It's not in the fourth quadrant. So you know that theta is equal to 338.2 degrees. So I have my magnitude and I have the direction. You get a problem like number 2 on the test, right? Thank you, Mr. Gantz. That's a nice, easy problem. Because you know you could just plot this, 0, 3. It sits right there. So obviously, what is the magnitude of that vector? What's its distance? 3. And what is the angle?
Pi/2.
Or 90 degrees. The last one, you can't just plot it. You need to do some of your formulas here. So go ahead and try the last one on your own. Brian, you got a cold?
I do.
How come? Who gave it to you?
I don't know.
Yeah.
I'm not sure.
I'm sick.
No. Nobody in my house is.
Softball team?
It's probably from being outside at some
Nobody on my softball team is.
Okay.
That I know of.
All right. I know you had a cold about a month ago.
Did I? No, Brian did.
I remember you two both sneezing away.
Oh.
I felt bad. So. Well, is it just small cold or a bad cold?
It's fine, yeah.
Okay, all right. So if I get a cold, I act really sick. There's
Man
no,
cold?
for me, there's no such thing as a small cold.
Man
I saw this thing and it was like, when I gave birth with no epidural or something, so I finally know how it feels for my husband to have the flu, and I thought that was really funny.
Yep. That happened to my wife. So the first baby, she didn't want an epidural at all.
The first one?
Yeah,
That's,
I'm like,
oh.
Kelly, are you crazy? She's like, nope. She's like, I just want it exactly like it is. She was in labor for 12 and a half hours.
No.
Oh, I would not have another child.
I'm making it up.
Oh.
I was like, oh my gosh. So anyway, second child, she's like, I'll take an epidural this time. So we get to the hospital and she's like, yeah, she'll take the epidural. No, she's like, she's too far
late.
along. Yeah, too late.
No.
So what happened with the third one?
Once you have the first two,
The next one just.
things just are, things go easier.
You're used to it.
Things go easier. So,
I
yeah.
was the last
Totally.
baby. I was a premature baby,
Yeah.
and I was 10 pounds.
You're a premature baby at 10 pounds?
Yeah.
You're a beefy boy.
How big was Hayden?
Hayden was 10 and a half, and Adler was 11.
Jeez
No.
Louise. There are so
Oh,
many
no.
things about pregnancy that are so scary.
Oh yeah.
It is incredible.
I was 6 pounds 8 ounces,
I was 6'6".
and I was not premature.
It-
How much were you?
6 pounds.
You realize in old days that people used to die from pregnancy. I mean, from labor, giving birth. I mean, it's a violent thing. It's incredible how safe it is nowadays, but I mean, it's a crazy thing. I remember our first one when we had our baby. I remember just being in the hospital, and it was late at night, and I remember we were all there, and there were 3 other families that were in there. They kind of same time they're having a baby, and so that next morning you get up, you're walking around, you're hearing just a little baby crying and stuff. But then helicopter came in because one of the babies needed to be. I don't know how things turned out, but complications with one of the pregnancies, so wanted to be flown off to Mayo. It's always hard. You just assume everything's going to go fine, but it's a hard business having a baby. It is. So anyway, so good for your moms. All right.
Who's listening to this video? I feel
Every once in a while I get a message from somebody.
Yeah.
They're like, yeah, we're checking your video. They're like, we got a story for you. They kind of follow up. So I get a fair number of videos actually from foreign exchange students.
Really?
They struggle to maybe understand their professor one way or the other in college and stuff. So yeah, they're still out there. So you guys are not the only ones who watch the videos. So every once in a while somebody finds one they connect with, they stay. So everybody got the 5 and the 53.13?
Yep.
Okay, so then sum and difference of vectors. I'll just show you a basic example. Suppose that vector A is 1, 3, and vector B is 2, -2. To find A plus B, you simply just add the 1 and the 2 together, and that just gives you 3. And then you add the 3 and the -2 together, and that gives you a 1, and that's your new vector. So all you do is just add the horizontal components together, you add the vertical components together. So in this example, we'll find the following using these operations. What do you think you do if it says 3 times A? Yeah, so you just get 3, 9. If it says 4B, you just multiply B by 4 and you get 8, -8. And if it's A plus 2B, then you take A, which is 1, 3, and you add to that twice the B value, which is 4, -4. Now as you add those components, you have 5 and -1. Why don't you do the last one on your own? I got -8, 16. You okay? You're in the dark. Oh, is it time?
Soon, like 10 minutes out.
Okay. Should we run outside?
Are we watching it?
It's kind of cloudy, ain't it?
It's cloudy, but it'll still get dark out. Darker. I think it's like 2:08 is the peak time, something like that.
2:01, I think.
2:01.
Oh.
Yes.
Well, there's like 7 minutes where it's the peak time.
Oh,
Okay.
that would make sense.
Well, should we hurry up and run outside then, or what?
Right.
Yeah.
Okay. All right.
Are we?
Vectors in terms of I and j. Suppose vector v is equal to CD. Then you could also express that as CI plus DJ. This is not used very much, but every once in a while you'll see it expressed this way. I've seen it once on an ACT problem, and I've also seen it expressed in your book. But normally it's not that big of a deal. I'm not going to show you a lot to do with this, but you'll see in just a second. The piece that you are going to have to do is come up with horizontal and vertical components of the vector, and I will show you that right here. Suppose you have a vector that is located at AB, and that vector, in fact, has a magnitude to it, and it has a direction we'll call theta. Is there a trigonometric relationship that you can use to express those 3 items together? Cosine. Namely that the cosine of theta is equal to A divided by the magnitude of the vector. And so if we multiply both sides by the magnitude, you get the magnitude of the vector times the cosine of theta is equal to A. Is there a trig formula that can relate these three items together? Sine, namely that the sine of theta is equal to B divided by the magnitude of the vector. And if we multiply both sides by the magnitude, we get the magnitude of the vector times the sine of theta is in fact equal to B. So what that means is the AB vector can be written as magnitude of V times the cosine of theta, and then magnitude of V times the sine of theta. So if you're wondering A and B, that's the formula that you can use to come up with A and B. So if you glance here, it says express the following vectors in component form, and then in terms of I and J. As we look at this vector here, it's not in that form. We need to come up with what A is and what B is. We're given it has a length of 3 and has an angle of 30, so where would it end up if it's got a length of 3 and an angle of 30? Well, we just use our formulas right here. We say that A is equal to the magnitude of the vector, which is 3, times the cosine of 30. Who here remembers what is the cosine of 30 degrees? So we have 3 times the root of 3 over 2. And you get 3 roots of 3 over 2. I now move on to another one. I say, well, I want to find B. And so I take 3 times the, cosine, I use the sine of 30. Everybody here knows what the sine of 30 is, right? 1/2. So you have 3 times 1/2, which is 3 halves. And that is the component form of your vector. Try the second one on your own.
Do we have to do it in terms of I and J too, or no?
I'll show you when you're done with that. You may know how many teachers are driving to see the eclipse? I think Mr. Fiskus is.
He's in
He's in
Mexico.
Mexico. He's
Yeah.
taking a cruise to like follow the path.
Is he really?
Yeah.
I think actually Miss Tran and her husband are doing too. Not the cruise thing, but driving somewhere. I got 2 roots of 2 and negative 2 roots of 2. You good? Cool. Flip it over. Last part. Back to where we started. Find the magnitude and the direction. Just kind of relate those together so you remember. Remember how I find the magnitude of V.
The square root of A squared plus B squared.
So square root of 1 plus 4. So I get the root of 5. As we move on, we want that to really be second nature, that you can do that quickly. We will have some application with word problems coming on up. And then we set up the tangent of theta is equal to B divided by A. What would B divided by A be? Negative 2. And so we go ahead and we figure out where tangent is negative 2 and which quadrant are we going to be working?
2.
Second quadrant. I inverse 2 for tangent on my calculator.
63.43.
63.43. So therefore theta is equal to 116.57 degrees. And our last one, the magnitude of this vector, square root of What do you get if you square the root of 3 over 3? 1/3. If you square negative 1, you get 1. What is 1/3 plus 1? 4/3. You could take the square of the top to get 2. But you can't leave the square root in the bottom like that, so you get 2 roots of 3 over 3. And finally, if you set up tangent of theta is equal to your b value, which is negative 1, divided by the root of 3 over 3. If you just type that into your calculator like it is, 1 over the root of 3 over 3 and inverse tangent that, you come up with theta is equal to 60 degrees. Thank you. And so we just identify the quadrant that we're working in, which is obviously the fourth quadrant. So we have 300 degrees is actually our angle. And that's it. You'll be more than prepared to go through your assignment at this point.